All right, welcome. This is same section 3.1 in Larson, and this is problem number 29 in section 3.1. We're supposed to find the absolute maximum minimum. Find the absolute maximum and minimum on this interval from -1 to 5 of this function. This is an absolute value function. And absolute value functions are favorites of calculus teachers, calculus exams, just because they're kind of confusing. So we'll talk about this and we'll go over absolute value functions a lot. So, keep working at it, keep asking me questions about them, and eventually they'll make sense. You might remember that you have the absolute value of x is equal to positive x if x is positive, and the absolute value of x is equal to negative x if x is negative. And I always thought that was kind of a dumb definition, but it actually works really well when you're doing weird stuff like this. So we're going to break this down into when this is positive. So when this turns out to be positive, we're going to use this definition. And so if t minus 3 is greater than 0, then we're going to say that this is just equal to positive x. So if t minus 3 is greater than 0, t is going to be greater than 3. Okay? And then if t minus 3 is less than 0, then we're going to use this definition here. And I'll show you exactly how that works. It's a little bit confusing. It always used to confuse me when I was first starting calculus. Another thing to do, another way to look at it is to see if we can graph this. If you can graph it, then you can kind of see what's going on. It's not that confusing. So we'll talk about graphing in a little bit. But let's do the calculus part first. So here we're going to say that let's look at t greater than 0, and we'll say greater than or equal to 0, because when it's equal to 0, it's just t is equal to 3. So we're taking this part right here, and we're saying, okay, let's just consider the function when t is greater than 3. Then y is going to equal 3 minus the positive value of t minus 3. Okay, so we say, when this inside thing is positive, the absolute value is just equal to t minus 3. What's inside there? So it's just positive of that, which means this function y is going to equal 3 minus t plus 3, which is going to equal, let me write it down here, negative t plus 6. Okay? So as long as t is greater than 3, it's just going to equal negative t plus 6. So that's this graph. Let's see what the graph looks like. Here's the graph over here. And this is 1, 2, 3, 4, 5, 6. And we're talking about when t is greater than 3, it's going to equal negative t plus 6. So that's going to look like this. It's going to be a function like this. 1, 2, 3, 4, 5, 6. And it's going to go from here to here, I think. Except up here it's not defined because there t is not greater than 3. So it's really just from this point right here down, and it keeps going, of course, forever there. Okay? So that's when t is greater than or equal to 3. So that's our function, y equals negative t plus 6. So that's what this graph looks like. If we graph that, that's going to be the right half of that graph. So that's what we're figuring out there. So what's y prime there? Well, y prime is pretty simple. It's just negative 1. So you can see that it's never going to equal 0. So not going to be any critical points there. There is, well, we'll get to this in a little bit, but there's not going to, this derivative is never going to equal 0, so you're not going to have a critical point. Okay? At least when t is greater than 3. All right, now suppose t is less than 3, then we're going to have this. Okay? So this is where that definition of absolute value becomes really important. So if t is less than 3, then y equals 3 minus this t minus 3, the absolute value we define as the negative. Remember, absolute value of x equals negative x if x is less than 0. So if t minus 3 is less than 0, which means t is less than 3, then we're just going to put a negative in front of that parentheses. Okay? And that's all you got to do. And you'll see what happens here in a second. So we do that, and of course this becomes positive. So it's 3 plus t minus 3. So y is just going to equal, the 3's cancel, just going to equal t. And of course that means y prime is just going to equal 1. So again, that's never going to equal 0, and there's no critical points there. What's this graph like? Well, it graphs just like this. Goes through the origin, has a slope of positive 1, and of course it meets this point right there. Now hopefully you look at that, and remember what I said today about the derivative does not exist any place the line is kinked. So this is a continuous function, but it's got a kink in it, and that kink means that there's no derivative at that point right there. So that is a critical point because the derivative's not defined. Okay? So that's a big deal. And you got to remember that. So no derivative at that point. So that has to be one of the places that we're going to check. We have to check when t equals 3 to see if that's a maximum or a minimum. Okay? So we're going to check the endpoints. Check where f prime is undefined. And that's where t equals 3. So we're going to check when t equals 3. And so what is y when t equals 3 is going to be, you can tell by looking at the graph it's going to be positive 3, but you can also put it in here. This is just going to be 3 minus 3 would be 0, so it would be 3 minus 0, which is 3. Okay? And then we have to check the endpoints. So we check the critical point where f prime is undefined, and we have to check the endpoints. So endpoints. So what is y of negative 1? And that's going to be this point right over here, and you can see it's going to be negative 1. But let's put it in here just to double check. So if I have negative 1 take away 3, that'll be negative 4. Absolute value, that'll be positive 4. So this is going to be 3 minus 4, which is negative 1. And then the other endpoint is going to be when t equals 5. So we're going to put 5 in there. It's going to be 3 minus 2, which is going to be 1. So that's right over here. So you can see the points here. The maximum is going to be right here. So that's the biggest of those 3 points. The biggest is positive 3, so that's going to be the maximum. And that, of course, is right here, and you can see that is a maximum for this function on this range between negative 1 and positive 5. And the minimum is going to be this number right here, negative 1. Okay? So here's the minimum, here's the maximum, and there's our other endpoint. Turns out to be neither. So think about that, take a look at that. If we have questions about it, we'll talk about it tomorrow.